Good evening once again. You are all most welcome to this specific session that we are going to have today. And today we are going to look at group 2 elements of the periodic table and their compounds. So we are going to look at which elements we find in group 2, what are their compounds they form, and then how do we use this compound, what is the need for us to study these different compounds. So let us start with the group 2 elements of the periodic table. Group 2 derived drugs. So we have an introduction to group 2 derived drugs. So group 2 elements are often referred to as alkaline earth metals because they form alkaline solutions with water, and they are formed naturally in the earth, and they are metals. Alkali earth metals. Another word for group 2 elements is they are called alkali earth metals, and this is the reason as why we call them alkali earth metals. Group 1 elements, we call them alkali metals, okay, because they form alkaline solution with water, and then they are metals. But this one, we call them alkali earth metals because they form alkaline solution with water, and they can be found naturally in the earth, as we are going to look at in the following slides. So the elements of group 2 include beryllium, having a chemical symbol of capital B small e, magnesium having capital M small g, calcium having capital C small a, strontium having capital S small r, barium having capital B small a, and then radium having capital R small a. This is their arrangement down the group. You find that the first element we find is beryllium, followed by magnesium, followed by calcium, followed by strontium, followed by barium, and lastly radium. So let us look at properties of group 2 elements. We have majorly 3 properties, though we also have others that you may encounter with as you keep revising. So here we are saying they are shiny as one of the property of group 2 elements, and then they have 2 electrons in their outermost shell and have an oxidizing state of +2, or they have a valence of 2. So group 2 elements, these elements are arranged in group 2 of the periodic table because they have 2 electrons in their outermost shell, or in their valency energy level. And since they have 2 electrons in their valency energy level, they are arranged in group 2 of the periodic table, and you find that they have similar chemical properties as well as physical properties. Find their reactivity down the group, electropositivity down the group. They have a specific characteristic that has made them to be put together in group 2 of the periodic table. So we are starting with magnesium. We want to know where we find magnesium. Since we have said these alkaline earth metals, we can easily find them on earth. So we want to know which minerals give us magnesium, and then after we have known, we shall look at how do we prepare magnesium, what are the uses of magnesium, and then what are the physiological roles of magnesium in the body. So here we have natural sources of magnesium. We have dolomite as one of the mineral. We have olivine as another mineral. We have magnesite as another mineral, and then seawater. So in case you are asked to list 4 natural sources of magnesium, at least we know what to write. We have dolomite, olivine, magnesite, and then we can also get it from seawater. So let us look at how we prepare magnesium. To extract magnesium, add calcium hydroxide to seawater. So we are manufacturing magnesium from seawater. To form magnesium hydroxide, precipitate called borates. Magnesium hydroxide is insoluble in water, and can be filtered out, and the residue reacted with hydrochloric acid to produce concentrated magnesium chloride. The concentrated magnesium chloride undergoes electrolysis to produce magnesium. This is when we are preparing magnesium. We can see from the equation of reaction. We can see from this equation of reaction. Alright, so we see that sorry about that. So we see that alright, give me a minute. We see that we have magnesium here, magnesium hydroxide, that we have formed reacting with concentrated hydrochloric acid to give us magnesium chloride and water. And then we have said this magnesium chloride undergoes electrolysis. So when it undergoes electrolysis, we know that for electrolysis to happen, we have both the cathode and the anode. And we have said at the cathode, we expect the cations to go or be attracted at the cathode. And then at the anode, we shall expect the chloride ions. The chloride ions at the anode give us or produce the chlorine gas. However, at the cathode, since it is our main emphasis here, at the cathode we expect to have our magnesium. We expect to collect pure magnesium. So what are the physiological actions of magnesium? What are the physiological roles of magnesium in the body? Why do we need magnesium in the body? Most abundant element, magnesium is the most abundant element by mass in the human body, and it is essential for all cells and some enzymes. So magnesium is essential for the growth of cells as well as other enzymes or some enzymes in the body. Magnesium ions interact with polyphosphate compounds such as ATP, DNA, and RNA. These are our polyphosphate compounds that we need to know. We have ATP, we have DNA, and then RNA. Magnesium interacts with them. That becomes another physiological role. We also see that enzymes require magnesium ions to function, just like what we said, they're essential for cells and some enzymes. So we see that enzymes require magnesium ions for them to function, and we know the work of enzymes. We know the role of enzymes. And then we see that we also use magnesium as a common laxative. Stroke an acid, an acid. We cannot stroke it because they mean the different things. So laxatives are drugs that are used to soften stool. So we can majorly give laxatives when we have our patients who are suffering from constipation or who are having constipation. We give them laxatives. And then antacids, here we are looking at cases of peptic ulcer disease. We know when we look at when we looked at group 7 elements of the periodic table, we looked at an acid that we said we can find in the GIT, and that is majorly hydrochloric acid. So we say that this hydrochloric acid is found in the stomach, and together with pepsin, it aids the digestion of proteins in the body or in the stomach. So by doing so, in case there are a lot of acid released in the stomach, there is need to use antacids to reduce the concentration of acid in the stomach. So you find that most of our preparations, most of our compounds that we use or that we give to our patients contain this component of antacid. Okay, for example, we have magnesium hydroxide, we have an antacid that contains both magnesium hydroxide and aluminum hydroxide. Yesterday, we looked at already a presentation talking about group 3 elements of the periodic table where we find aluminum. So we also talked about a compound of aluminium being aluminium hydroxide, where aluminium hydroxide also is used as an antacid. So you need to appreciate or understand the physical actions of magnesium in the body, and it is good to also know how relevant it is, and know a few food items that enable us get magnesium, so that you can recommend your patients who may require it when they come to you. Or not only your patients, you can also use them yourself as well as people around you. So that takes us to magnesium compounds. Magnesium has a quite number of compounds. We have magnesium hydroxide, we have magnesium oxide, we have magnesium carbonate, we have magnesium sulfate. As pharmacopoeia preparations, the main area of interest in magnesium sulfate and magnesium trisilicate, that is what we are going to look at majorly. However, we are going to look at how magnesium sulfate is prepared, what are the natural sources of magnesium sulfate, and those other things that we are going to look at. So we are starting with one compound of magnesium, that is magnesium sulfate. So we see that magnesium sulfate, the natural sources of magnesium sulfate, we have seawater, we have minerals, we have satellite, we have kerrisite, we have epsonite, and then we have epsom. So all these compounds, this calcinite, another word for it is magnesium sulfate monohydrate, and then epsonite, we have magnesium sulfate heptahydrate. So all of them have water of hydrolysis, and then this epsom has magnesium sulfate hexahydrate, meaning hexa, this one has 7 molecules of water. I mean 6. Hexa is 6. A hexagon is a 6-sided polygon. So this one has 6 water of hydrolyzation, or molecules of water of hydrolyzation. This one has heptagon is a 7-sided polygon, so it has 7 water or 7 molecules of water in a compound. We are talking about water of hydrolyzation. And then for magnesium sulfate, we see that it has one molecule not one water, one molecule of hydrolyzation. Okay, so let us see how we can prepare magnesium sulfate. Magnesium sulfate can be prepared by neutralizing sulfuric acid with magnesium carbonate or oxides. If you can either have magnesium carbonate or magnesium oxide reacting with sulfuric acid to give us magnesium sulfate, carbon dioxide gas, and water. So magnesium sulfate produced undergoes crystallization to dryness. So you find that this carbon dioxide is evolved as a gas. So this should be a gas, is evolved as a gas, and then we have our water as a liquid. So we find that what we shall remain in solution, because this will be evolved or will be collected, the gas will evolve. So what will remain is magnesium sulfate and water. And for us to get crystals of magnesium sulfate, we shall have to heat magnesium sulfate to dryness to evaporate the water. Like here they have talked of crystallizing out magnesium sulfate. It's the process of heating to dryness in order for us to obtain magnesium sulfate as our salt. So we have uses of magnesium sulfate. Magnesium sulfate is used as anticonvulsant agent and then used to treat skin inflammations or boils. It is also used in bronchodilator as bronchodilators. Bronchodilators are majorly given to conditions that bring about bronchoconstriction. For example, in cases of asthma, we see that the bronchi in the lungs is constricted. So for us to manage it, we give them bronchodilators that enable to dilate. And we also have other conditions apart from asthma that bring about bronchial constriction. So we look at making it dilated. And then have anti-acid properties. We already talked about the anti-acid property, and this magnesium sulfate as well can be used as a laxative. And laxatives are those medicines or those compounds that are used in management of constipation. And how they help the patient who has constipation is when they soften the stool. So magnesium sulfate is always produced in form of powders. This is how we find magnesium sulfate. The dosage form is solid dosage form, and to be more specific, it is in powder dosage form. Because we have majorly 3 types of dosage forms: liquid, solid, and gases. So under solid we have semi-solids. Under liquids we also have those other different sections. So this takes us to magnesium trisilicate. This is an inorganic compound that contains magnesium, oxygen, hydrogen, and silicon atoms. So what's the use of magnesium trisilicate? Magnesium trisilicate is used as a gastric antacid that neutralizes the gastric acid produced in the stomach during treatment of ulcer. So we see that magnesium trisilicate is majorly used in management of peptic ulcer disease. So let us recap a bit. We have looked at sources of magnesium, and we gave sources of magnesium as dolomite, olivine, magnesite, and seawater. And after that, we have looked at how we can prepare magnesium, and we said we can prepare magnesium from seawater. After that, we also looked at compounds of magnesium. We said that magnesium has a number of compounds. We have magnesium hydroxide, magnesium chloride, magnesium sulfate, magnesium trisilicate. However, our main aim or our main emphasis is on magnesium sulfate and magnesium trisilicate. So we looked at the different sources of magnesium sulfate, where we say that under magnesium sulfate we have majorly a number of sources, some of them having water hydrolyzation, where we have a hydrated magnesium sulfate. And what makes a difference is how many molecules of water are in each. For the hepta, we have 7 molecules of water of hydrolyzation. For the hexa magnesium sulfate hexahydrate, it has 6 water molecules of hydrolyzation. And then magnesium sulfate monohydrate, it also has 1 molecule of water of hydrolyzation. So those are some of the sources we looked at. We also looked at the physiological roles of magnesium, and we gave a number of them. And then after that, after we prepared magnesium sulfate, we looked at the uses of magnesium sulfate, and then we came to magnesium trisilicate. I hope you don't forget this. Let's meet for calcium and its compounds. Thank you for listening.